Now we'll look at question 4 of the paper. Question 4 shows a book on a table as shown in figure 4.1. So with reference to Newton's third law, we will have to complete the following statement about the reaction force to weight of the book. So when we first see the term weight, we should be able to identify that the weight of the book is actually a force by the earth on the book. So therefore, by the Newton's third law, the reaction force to the weight of the book will be acting on the earth by the book. And from Newton's third law as well, we know that it has the same magnitude but acts in opposite direction. So this will be the answer for question 4a part. We look at question 4b. The book is now pushed to the right by a constant horizontal force of 20 Newton and experiences a frictional force by the table. On the free body diagram below, draw and label arrows to identify all forces acting on the book. So we first read the first statement. The book is now pushed to the right by a constant horizontal force of 20 Newton. So the first force I can easily identify is that the book is being pushed to the right by a force of 20 Newton. I call this force F. And on top of that, we also know that the book also experiences a frictional force by the table. So based on this statement as well, I know that there is also frictional force acting on the book by the table. I will call this the frictional force. On top of that, we should also be able to identify that the book itself has a weight which will act downwards from the center of gravity of the book. And lastly, because the book is touching the table will also exert a normal contact force upwards onto the book itself. So this will be the answer for question 4 part B. For question 4 part C, given that the book experiences a constant frictional force of 10 newtons and experiences acceleration of 2 meter per second square, calculate the mass of the book. So first, we know that the rightwards force given by the question in part B would be 20 Newton. And we know that this frictional force here is 10 Newton. So therefore, the resultant force acting on the book is equal to the 20 Newton towards the right minus away the 10 Newton frictional force acting towards the left. And therefore, my resultant force acting on the book will be 10 Newton to the right. And we know from Newton's second law, by the formula, resultant force is equal to mass times acceleration. The mass of the book is equal to the resultant force acting on the book divided by the acceleration of the book, which in this case we have found that the resultant force is 10 Newton, whereas the acceleration of the book is 2.0 meter per second square. And therefore my answer will be 5.0 kg, which will be the mass of the book. And that will be the end for question 4.